Okay, so we are live now. Uh, good evening, everyone. I am Yash Khandelwal. On behalf of Society for Data Science, welcome you all to for today's session. As you all know, that we Society for Data Science are a student community of data science enthusiasts, where students from broad majors share their common interest in the field of data science. We aim to bring more and more students an opportunity to explore and learn data science. So now, today we have a session on how to start exploring regional AI, and our speaker is Ms. Ramya Victor. So let's begin our webinar. Over to you, ma'am. Sorry, your mic is off probably. Please switch on your mic.
Thanks for letting me know. Yeah. So hi all, myself Ramya Victor. I'm a senior MTS at VMware as well as the city director for Women Who Code Bangalore chapter. So AI is something that I like to explore during my free time, and we do a couple of mini projects back with my group where we try to learn new things happening in AI ML. So today's talk is just a brief overview on regional AI so that you get to know there's something called regional AI and what exactly is there in it. This is 101 regional AI. It is not a deep dive. So after this session, you should be able to explore and delve deeper and do more research on it. So let's get started with the talk. I will be stopping my cam and sharing my slides. So just bear with me for a sec. Yeah, I see my slides are being shared. So let's directly jump to our session. So as you see, it's Explore Regional AI. So Pratik Basha Prasankaran is nothing but the regional name for NLP. So today's agenda, we're kind of going to delve into what exactly is NLP, what is regional NLP, and how can you get started with regional NLP, and what are some of the upcoming things that you can explore in regional NLP. So let us exactly see what exactly is NLP, right? Most of us might know, but just for the benefit of others who don't know, I'll just explore in a brief line what exactly is NLP. So NLP is also known as text analytics. So it is a field of computer science that basically tries to understand human language. It could be verbal, it could be textual. And how it tries to understand is it uses a model or a program so that it can understand the human language and retrieve some useful insights. But by doing so, what is it going to accomplish? It's going to perform a particular task. So in a layman terms, it tries to understand human language using a model so that it can retrieve some useful information and perform some action accordingly. So that is what is NLP for you in layman terms, right? So if the definition didn't quite get to you what exactly is NLP, then probably this examples will give you a good idea is of the use cases of NLP. So you would have seen multiple applications of NLP in your life, but you might not know that the underlying tech is nothing but natural language processing. So the applications of NLP range from a simple text translator to advanced applications like the chatbot assistants that you see in most of the websites that you log in now. And it could be even such as an autocorrector, or it could also be a recommendation system. So beautiful example for that is you would have noticed when you log into Facebook, right? The advertisements that pop up for you are not exactly same as the ones that appear to your friends, because the logic behind that is called as targeted advertisement, where they monitor your social media activities, and using recommendations they kind of project only the targeted advertisements in which you would be interested in based on your history of the social media usage. So this is one of the good examples that we can correlate when we talk about NLPs. So along with this, the other examples are voice assistants such as Alexa or Google Home, and even email filtering, as simple as the spam email categorization that happens in your Gmail. So, and even sentiment analysis is one of the very well known applications of NLP. So, the use cases and applications of NLP are vast. So, it's very good to explore NLP and know more about it. So, I hope you were able to get a mapping of what exactly is NLP used for, having looking at this slide. Since we spoke what exactly is NLP in a one liner and what are the applications of NLP, let's just go deeper to see how exactly NLP does all this. So, when NLP has to explore and understand the human language, right, it has to perform a set of operations. So why does it perform these set of operation? Because it's very important to understand that a text cannot be directly processed by a computer or a program, right? Because computers or program just understands zeros and ones. So it is very important that our data are converted into that format, right? Our textual data. So when we are processing this data into these binaries, and there are a number of steps that are being performed. So for the language processing, these are the steps that are being addressed here as shown in the image. The first one is the sentence segmentation. So what exactly is sentence segmentation? I'll just give you a brief liner. So we will say we have a huge paragraphs, right? So, and we do want to pass the entire paragraph for our program to process, right? So for that, we kind of divide our entire big sentence, or we call it as a corpus or test data. So we take that data and divide it into smaller paragraphs of different sentences, right? So it is basically you're dividing your big corpus into smaller segments of paragraphs into separate sentences. So if I have a paragraph of 4 sentences, it will be divided into 4 separate sentences when you do sentence segmentation. Okay, so that is simple as that. Dividing a paragraph into sentences is called sentence segmentation. Okay, so next, what is word tokenization? So once we have sentences, once a paragraph is broken down into sentences, now we want to break the sentences into much smaller segments, right? That is nothing but word tokenization. So you divide the words in your sentences into individual units of processing, right? Suppose my name is Ramya Victor. So you divide there my name is, so my is a separate word, name is a separate word, is a separate word. So each of them become a smallest unit of processing. So dividing a sentence into small segments called words is nothing but word tokenization. So that is the second part. And then you have text embedding. So what exactly happens is you need to represent this text in a vector format. So what we do for that, there is a process called embedding. So embedding can happen as a word embedding, or it can happen as a sentence embedding. So you all must have heard about transformers. That is something which does an entire paragraph embedding into a text embedding. You don't have to break that into smaller unit called words and then do word embedding. You can just take the entire text and convert it into your vector format using the transformers. So the vector representation of the word for easy processing later is called as text embedding. Okay, and the next one is stop word removal. So in any language, so for example the English language, we take, there are a lot of stop words, right? We don't want to stop words because at this time of processing the stop words might not be much relevant for us, so we remove it in the initial processing. So the stop words could be like the articles like the and all these articles in English language, they can be stop words that we want to remove, or even a full stop or an exclamation mark, right? They all might be stop words which might not have relevant information at this point, so we want to remove them. So stemming and lemmatization is, for example, I have a word celebrate and it has multiple forms, right? Past, present, present participle. These are all the different conjunctions of English language, right? Celebration, celebrating. So these are the different forms of the word celebrate. Celebrate itself can be used as celebration, celebrating, right? So when I'm doing the textual processing, I'm not interested in the various format of this word. Rather, I want the root form of the word. So when I'm seeing I'm going to celebrate, here celebrate is in the root form, but the celebration was very nice. Here celebration is not in the root form celebrate. It has iong in the end, right? So I want to remove all those things and just have the word celebrate when I'm counting the words in my corpus, right? Corpus is nothing but your data set that you're trying to analyze. So eliminating all the various forms of a word and getting back to its root form is nothing but stemming and lemmatization. There is a very minute difference in that. So stemming kind of chops off the last variations like iong, ing, and all. But lemmatization is kind of like the dictionary format. It doesn't just chop off the last words. Like celebration, I want to get the root form of celebration, which is celebrate, right? It goes and checks like the actual form of it is celebrate. So it gets the celebrate form. It doesn't just chop off iong from celebration and gives you the remaining words as the root form. So that is the minute difference. So it's more of a processing difference. So n-grams is nothing but two words will always appear together. So we want to keep those two words together when we are processing, right? So for example, you take New Delhi, right? New is a separate word, Delhi is a separate word. But when I'm referring to New Delhi is one city that I'm referring to. I want to keep those two words together when I'm processing. I do not want to kind of tokenize them separately and create a different set of meaning, right? So for that, we use n-grams, and post tagging is part of speech, whether it's a verb, whether it's a noun. So we do that analysis using post tagging, and dependency parsing is as simple as there's so many words in my sentence. How are each word related to each other? So for example, I tell the cat is brown, full stop, and then I tell it has very soft fur on it. I mean, cats don't have a fur. So it has a very soft texture of hair, right? So when I'm telling it, it refers to the cat. So the mapping of all the words in the sentence, how they're correlated to each other, that is accomplished using dependency parsing. And name entities, like when you want to know what are the words used in your sentence, whether they refer to the name of a person or an institute. So for example, you're telling Apple is a very awesome company to work in. So here, Apple, you need to understand whether Apple is the company or Apple is the fruit. When you just look at Apple, right? So the name entity recognition is basically used to correlate and understand whether the words that are there in the sentence are the named entity of a person, company, or a place. So these are some of the steps that are being used in NLP. So you might be wondering, I'm talking about regional NLP, but why are you talking about all this? So you'll get to it why I'm talking about all this when I just go a little bit further in my slides. So just bear with me. So now is the part where I'm going to talk about regional NLP. So the majority of the breakthrough and the state of the art frameworks that presently exist for NLP are majorly developed for English language. So I'm telling majority, I'm not telling all, because there are exceptions. So what exactly is regional NLP? Why do we have the need to have a separate subclass of NLP called regional NLP? So we human beings by nature, we are very diverse and we are multilinguistic, right? We speak different languages based on the regions we stay, based on the country we stay. So if you just look at the Indian subcontinent, as I've shown in the image, right? We have so many of our neighbors like Bangladesh, Bhutan, Maldives, Nepal, right? So there itself, there's so many variations of the language. Just if you take the Indian subcontinent, right, India along with all the other neighbors, there's so many languages. And even within India itself, right, there is a multitude of languages that are spoken. So, and if you just go by the Indian country, if you just go to the different regions, right, each region itself has so many languages. So that itself shows, right, there is a need to have a regional NLP so that we can catch the nuances and the different vernacular languages that have the different knowledges which are written in the local languages, right? Because each of these vernacular languages that the human beings speak, right, they cannot be directly kind of passed using the traditional NLP models because they're kind of confined to English, right? Because processing these vernacular languages that we as humans speak based on the locality that we stay is a little bit difficult. Why? Because these vernacular languages, they have a different dialects. They're not very similar to the English that we all know about, right? So that's why there is a need to have a separate class of NLP called the regional NLP. So the progress of NLP for this regional languages, right, is was basically constrained by the non-availability of large scale data sets, because when we talk about NLP, right, we need to have a large data set which we can study, and we need to have some reference models, like for example we have birth models against which we can kind of do a correlation and study, right, when we are processing the language. But when you take into the regional NLP, pretty much you didn't have a standard reference model or a large data set that you can use in order to build a model for it. So that was the basic essence or need why many of the researchers started working on regional NLP, and they came up with various libraries to process this vernacular languages which cannot use the traditional NLP models, which are basically developed for the English language, right? So that was the basic essence, to have the regional NLP section for the NLP, so that you can understand the vernacular languages. So why do you have to understand the vernacular languages? Because the heritage and the culture and the history of that particular locality is captured in that local language. So if you want to kind of archive the traditional history and all of them in a faster way, right, if you had an NLP program that could kind of parse their text, say for example Karnataka Kannada text, it can parse and it can kind of archive all those data and store it. It is so easier, right? And if you want to develop any software, it would reach to that mass if it is there in the local language, right? Most of the people would start understanding and using it, and technology spreads to larger vast, even to the smallest of the person in that particular state. So these are some of the need why you need to have a natural language processing for that particular region. So having said that, right, we need to have a regional natural language processing. So next comes the challenge, right? Is it so easy to process the regional languages? Definitely not, right? There's some of the challenges associated with the regional languages. For example, the phonetics of a character, right, which describes the property of that character, like how the character sounds, whether the character is pronounced from the throat when you roll your tongue. So there are certain words in, say, Hindi and say Kannada, right? The way you pronounce matters. It otherwise it sounds different, like na and na. If you know Kannada, that is the two characters, right? Where the pronunciation matters a lot. So that's basically called the phonetics of a character, right? So you need to know how exactly the character is pronounced, right? And how it exactly sounds, right? So all those inference you should do when you're trying to process the regional languages, because see, the Indian subcontinental languages, right, if you take, they have very strong phonetics for their alphabets, right? So when you are doing an NLP processing of the Indian language, whatever library that you are using should capture all these aspects of the language. So it can capture these aspects of the language in a vector. So generally they use phonetics vector that is associated with each of the character, which captures the various properties of that characters. So all of this need to be accounted when you are doing processing of regional language. So that cannot be done using the legacy NLP models, right? Because they do not capture that aspect. So all these additional features had to be added in the NLP. So that's why it was good to have a regional NLP which tackles all of these things. So that is the another reason why people kind of move towards having a separate section. And another thing is the use case of regional NLP is slightly different. For example, we all know that translation is pretty common when we're talking about generic natural language processing. So translation is nothing but the one you can see in the yellow box. So there is an English sentence like, "We'll talk to you tomorrow." So translation is nothing that I say that my source language is English, but I want the exact meaning of this sentence in Hindi. So, kal aapse baat karenge, right? So the meaning is same, but it has translated it into a local language. This is translation. This is one of the common use cases when we generally talk about NLP. But when you talk about regional NLP, there is another addition to translation. There is one more use case that is more relevant, that is transliteration, right? What exactly it means? Say there is an English sentence like, "We'll talk to you tomorrow." Okay. I'm a person, I can read only Hindi. I understand English. Okay. but I cannot read English, but I understand the English words. I know to speak, but I don't know to read. So for me, if you translate this will talk to you tomorrow in my Hindi language, and when I read it, I can understand, oh, they're telling will talk to you tomorrow, because I understand English words, but I just don't know to read English, right? So if you see that blue box, it tells, right, in Hindi it is written will talk to you tomorrow. The same English sentence is written as it is, but using the Hindi characters. So for a person like me who wouldn't know how to read English but understands the English words, for such person the transliteration is a very good example, right? This is one of the common use case for the regional NLP. So all these additional features should be added so that it makes good sense to have the regional NLP to be used by most of us and enhance it further, right? So having said that, what is NLP, why do we need regional NLP, and what are the few challenges, right, which are kind of being mostly addressed now, because regional NLP is not something which is kind of newly started, it's been there for some time. So since all of these have been already being dwelt by few researchers, there are some handful of Python library. We do not have a vast collection, but we do have some Python library which kind of does the text processing and builds the NLP languages here. So we are kind of looking at the Indian language when I'm talking about regional NLP here. It could be anything depending upon which language you're trying to explore. So here are some of the libraries that you can kind of start looking at if you want to see how to do more research on NLP, which is confined to the Indian languages, right? So the first one is the INLTK. So INLTK is nothing but the natural language toolkit for Indian language, which is similar to the NLTK that you would have used predominantly. If you have been working in this NLP, right, you would have definitely used the NLTK package. So this INLTK is nothing but the Indian language processing package for the NLTK version. Okay, it is very commonly being used across multiple applications. Okay, but when you're trying to use this, there are multiple dependencies that you need to know, like it has dependency on PyTorch and all. So you will have to download the according packages to use this particular library. But once you just do export of this, it is very simple. It is as simple as just doing the NLTK package dot the function call, and it will process your Indian languages, right? And it is a very intuitive and easy API interface, because its corresponding NLTK Python package is very popular. So using the INLTK is just a variation of it. So most of them will be very comfortable using it. And as of now, INLTK supports tokenization, word embedding, text completion, and similarity of sentence, whether two vernacular language sentences or Hindi sentences, for example, are similar or not. So that also it performs. Then another one is Indic NLP library. This is also pretty famous. There is very good documentation on it, which you can explore. So this also deals on how to process the languages pertaining to Indian subcontinent. So it also supports normalization, transliteration, and phonetic analysis, like how I described earlier. And it also talks about the syllabification. So syllables are the individual characters. So it talks about that. And normalization, as most of you would know, normalization is kind of taking your big sentences. If you take about regional languages, right, for example the Hindi, there are a lot of they call it as dirghas. So the writing way is slightly different. Okay, they kind of cause a noise when we are doing processing of these languages. So how do you handle such noise in the data and kind of don't lose out the information of it? So that is called as normalization here. It is slightly different from the normal normalization when we talk. So here in regional languages, how do you kind of process the characters in such a way that the some of the language nuances are not lost, but yet you remove them in such a way that processing of the text becomes easier. So that is what normalization here talks about in the regional AI. And another one is the Stanford NLP. So that also deals most of the things like how we spoke about lemmatization, parts of speech. So these are some of the libraries which handle most of the things. But one thing to note is not all libraries are supported for all the Indian languages. So that is very important to note. So I will probably show you the brief examples of how you can use the Indic NLP library. So these are some of the functionalities that is being supported by the Indic NLP library that I can show you when I'm showing you my Colab note. So as I said, right, all the languages are not being supported by the libraries that are being displayed over here. See, for example, if you see, right, you have the script information. If you look at the second box, so Indo are, if you see the first box language, so basically the Indian languages are supported uh, as Indo-Aryan languages or Dravidian languages. These are the subcategories when we talk about Indian languages, right? So under Indo-Aryan, you have couple of languages which are being spoken by Indians, and under Dravidian, you have a couple of languages being spoken. So when we are talking about regional AI, right, you'll have to take each of these languages and see which of the features are being supported. Say, for example, if you see the second box, right, in the second box, we talk about normalization. For normalization in Urdu language, there is no support that comes under an Indo-Aryan language. So for example, if you're processing Urdu text using the particular library, that is the Indic NLP library, right? Indic NLP library does not support normalization for Urdu, but it supports normalization for Hindi. So when you're trying to use these packages which are already present, right, you should always make sure that you go back and check whether the language that you're trying to process has the operation that you're looking for, whether it supports tokenization, whether it supports word segmentation, right? See, for example, word segmentation is again not being supported for Nepali, for Urdu, for Assami, right? And if you're trying to process the Nepali language and trying to do tokenization using this Indic, it will not work. So it is like wasting your effort, right? So first, always go back, check the documentation to see whether it is being supported or not, and then go ahead exploring it. So this is like a research oriented area. People are still exploring, people are still trying to do a lot of things. So it is one of the good areas to explore on what you can do more in this particular language. But this is a very good example table that you can always go back and check. So I will do a brief on Indic demo, and then I will just probably tell what exactly we are looking for going forward in regional NLP. So just one second, let me just quickly share my Colab. Okay. Yeah, just give me a second. I'm just sharing my screen. Okay, I see. Yeah, the screen is shared. So this is a very simple library that I've just imported and tried to perform few steps just so that you get a brief idea of what exactly it is. So I've done a pip install of Torch. Okay, this is Colab. You can just go to Colab in Google and you can open it, and most of the environmental issues are eliminated when you use Colab. You don't have to install them manually. Because it's a runtime environment, you just run the command and it does most of the things for you. So it's a good place to explore things here. So I've done just a pip install Torch, and see, installing INLTK is as simple as pip install INLTK, and installing its dependency Torch. So I am just going to show you the Indic library. So to install the Indic NLP library, you have to just do a pip install Indic NLP library, and that's it. It gets all the packages for you. This is the Python version. So it gets all the packages and you're ready to go. So if you want to use the Stanza, the Stanford one, this is what you do: pip install Stanza, and you can start exploring on that. So when you install the Indic NLP, right? So we saw tokenization is one of the steps in natural language processing. So how would you do that for the regional languages? So once you installed it, is as simple as an import, right? So you just go to the Indic library tokenization and you import that particular token. So, and then say, for example, your statement is this Hindi statement, right? Suno kuch आवाज आ रही है, कौन? So it's just that, like it's just telling that, listen, I hear some sound. Who is this? So that's what is the exact meaning of that sentence. So that's the input sentence, and you want to kind of tokenize it. Say divide it into very small units of processing, which are nothing but your words, right? So for that, all you have to do is call the trivial tokenize and pass your input statement, right? And since you want to print each of the words that it returns, you just iterating it over a for loop. So once you do that, you just print and see, and it is like input string is this, and your tokens are the words along with the comma, and this is full stop in Hindi along with this and question mark, because we have not removed the stop words, right? We are just kind of tokenizing, just splitting the smallest unit of processing and printing it. So this is what you'll get for tokenizing. This is a word tokenization example, right? And similarly, if you want to do a sentence tokenization, so you have a big sentence. I'm just not going to read out that sentence, but it's like a pretty big sentence here you have, and you want to tokenize this sentence, right? It's a very simple use case for, I mean, it's a very simple step of NLP processing. So you want to split this into individual sentences, right? So all that you do is call the sentence split, which is a sentence tokenization function present in the Indic library. So you call that, but one catch here is you, because it supports multiple languages, right? And the full stop in the languages varies. Say, for example, in Hindi, the full stop is a line like this. If you could see, it's like a one, right? But for Kannada, it's a full stop. For Tamil, it's a full stop. So in order to divide a big paragraph into sentences, you need to know which is the stopping point of a sentence, right? For that, you need to know which language. Here, the need for the language comes into existence, right? Because if it is Kannada, then you will understand that, okay, the full stop, the normal English full stop is the stopping point for a sentence. But if you try to search in Hindi, right, you're not putting a full stop anywhere, right? Because in Hindi you're just going to put one line, that is the full stop. So when you're doing sentence tokenization, there is a need to specify the language, right? Because you should understand the stopping point. So that's why we are passing a parameter called lang equal to hi. So it is a keyword. For Hindi it is hi, for a different language it is a different word. So you need to refer to the documentation to know to pass which one. So hope you got to know why we are not passing language here, because for word tokenization, it's just going to see the spaces and it's just going to split the sentence, right? But for sentence tokenization, it needs to understand when exactly a sentence stops. So for that, it needs to know the language so that it can map that language to the full stop represented in that language. So once you do that, you just iterate it in a for loop and print all the sentences. So this is as simple as sentence tokenization. I'm pretty much showing it for Hindi. So you can kind of explore the other languages that are being supported in that particular library. The another one is detokenize. So sometimes we split a sentence into small words, right? But then we want back the sentence again, right? So that is nothing but detokenize, to be in a very simple term. So that detokenize is also a simple library that you can get from Indic tokenize. So you just get that particular function and call that in your statement, and it's as simple as that. It just detokenizes your string and you get back your string mostly. Okay, you get back mostly the same string. Why I'm telling mostly is sometimes if you, when you're passing your tokenized string, right, in case you don't kind of pass the exact words, if you don't pass this comma and all, so the detokenized string, you will not get the comma, right? It not be like formatted, it will be like, it will miss out this. So for detokenize, it pretty much depends on what exactly you're passing, right? You need to, whatever initial sentence you have split, the same sentence you have to pass it, then you'll get back the original sentence. If you remove some of the stop words from your tokenized sentence and you try to pass it to detokenized string there, you will not get the original because stop words will be missing. So that's why I told you will get exact, you will not get exactly, you might get almost the same original sentence. So another thing is the transliterate, right? As we saw in the slide, it is nothing but translating the given sentence as is in the in the destination language that you have mentioned, right? So here, say we have a input string called Rajasthan, okay, and then you want this to be translated into a different language, say Kannada, right? So HI is for Hindi, KN is for Kannada, and your input string is Rajasthan. So transliterate is nothing but the word is written as it is in a new language. It is not converted to the equivalent meaning in the new language, rather it is written as it is, right? So if you see in Kannada, if you know to read Kannada, this is also the same. It is called Rajasthan. So it is just given the word as is in the Kannada language. So this is called transliterate. So it's like that you can kind of try to explore each and every particular feature that we spoke about in the different steps of NLP, right? In transliterate, we have multiple functions, right? We have the unique translator and we have itrans translator. So you can see here the input string is nothing but, if you see here, the words are, few are in small case and few are in uppercase, right? So if you see them, we want to get the corresponding numeric representation of these particular letters. Okay, so if you want to do that, we can use the itrans translator. And if you pass to that and you mention my language is ML Malayalam, right? It gets the corresponding number format for that particular word, right? So if you see Palakkad, and this is actually written in English only, but the language that we are referring to is Malayalam. So it converts that into those particular numerical representation of those particular words. So that is what you get over here. So this is one more example to elaborate. So this is another transliteration from Hindi to Telugu, if you see, right? So you pass the Hindi text and you kind of translate and it comes back into Telugu, the exact words, but written in Telugu language, right? And this is another example which is kind of combined. It takes a string and kind of does tokenization, and after tokenization we are printing the statements here, and we are kind of seeing the word frequencies using n-grams, and we are seeing bigram frequencies. So that's what like how frequently two words occur together and what are those two words. So this kind of prints all those words and their frequencies. So this is what I meant by frequencies, right? It takes two words and see how frequently they appear. So in my sentence, I have a comma, so it is taking suno comma and seeing how frequently that occurs in a statement. It occurs once. So it's kind of doing that n-grams that we spoke about, and it also does the word frequencies, tells how frequently a word is repeated in a particular corpus. So corpus is your input text. How frequently is that repeated? So for word frequencies are used in order to do the occurrence matrix, which is one of the steps in NLP that we do while processing the word embedding. So their word frequencies are useful. So if you want to kind of do all those things for the regional NLP, these are some of the libraries that you can actually go back and explore by passing the languages that it supports. So you'll have to go back and check the documentation to make sure that you are using the right library for the right languages. So, and the other thing that I would like to show is that this is the hands-on that I wanted to show, and the last thing I wanted to show was in the slides. I'm just sharing my slides. Just bear with me for a moment. Yeah. So yeah, just one sec. So what we spoke about so many libraries and all those things, right? So you might have a thought that okay, there are so many libraries, but why aren't the existing libraries that is being mostly developed by, say, Google, Facebook. Why are they not catering to regional NLP? Well, they are catering. So one such example is the multilingual representation for Indian languages, okay, which is a free and open source learning language tool, which was specifically designed for Indian languages, okay, and it was launched by Google in the year 2020. So what is its main purpose is it helps to build local technologies in the vernacular language with a common framework. Like, for example, we know some of the common frameworks like the birth, right? So Google has trained this multilinguistic representation for Indian language. In short, it is known as Muril tool, using existing learning models such as birth. Okay, so because it is trained using existing language, the its performance is better and it is well adaptable. Okay, so other companies also are working towards regional NLP, and they're doing a lot of research in that. So I just wanted to kind of end my talk by giving you a brief on what exactly is regional NLP, what you can do with it, and what the big top companies are actually doing with them. So that should give you a good idea on how you can go back and explore more and try more things on regional NLP and kind of build some of the applications around them. But having said this, right? Yeah, regional NLP has one downside, that when you are developing some application, it's more confined to the language that you are developing, right? The Indian language, if you're doing it is more confined to Indian language, it might not be easily adaptable to the other languages. But having said that, if you look at the bigger use case, right, you want to kind of have applications developed for a vernacular language, so you're trying to accomplish that using regional NLP. Yeah, it cannot be easily used for the other languages unless it has been trained with it. That is one drawback. So there is a pro and cons. It is not always only pros or always only cons. So depending upon the thing that you want to accomplish, you want to build something for the vernacular language, obviously you are going to develop something only for, say, Indian languages, and you're going to accomplish it. Yeah, the con would be that it is not easily adaptable, say, for the other languages. So that is one thing that you have to keep in mind when you're exploring it. So on that note, I would like to conclude my talk and hope you had a good insight on what exactly is regional NLP, what exactly is happening, and how can you kickstart your journey into that. Yeah, so that's it from my end. Hope you had good time listening to me for almost 45 minutes. And if you have any questions, feel free to ask me. If I am aware of it, I'll definitely answer to it. If I'm not aware, I'll go back, I'll do my homework and probably update in any forum that is possible that would reach out to you. Thank you.
Hello. Thank you, Ramya, for sharing your knowledge. We are grateful to have you.
Thank you, Aditya.
Yeah. I am waiting for anyone to ask question. Please be with us. We are waiting for anyone to ask question. Yeah. Hello, Ramya.
Yeah.
We have a question.
Mhm.
So, what are word tokenization techniques?
So you mean to tell the examples that are being asked? Can you just ask them to elaborate?
Yeah, 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 yeah. So we have next question by Shivam. The
Mhm.
question is, which among stemming and lamination is better to use in real world scenarios?
So it completely depends on your use case, right? So stemming, what it does, as I said, right, it's just going to chop out the words in the end, right? If your use case lies more on just processing the language and responding to the customers, right? So for example, you're developing a chat bot, and your chat bot should understand everything that the customer says and should get the complete context of the customer speaking, right? That time what you have to do is you have to use lemmatization, because you need to understand whether, because see, the past tense and the present tense of a word matters a lot in English sentence, right? So if you are trying to get the complete picture of what the customer is trying to tell, complete context, and respond to it, if you're building an application like that, then you will have to use lemmatization. But having said that, lemmatization is a bit slow, understand, because it is going to do complete processing and give you the exact root cause. It is more like searching in a dictionary and giving you the correct root form of a word. Okay. But if you're building a lightweight application where the application has to just kind of predict, if you're typing something in your mail, and it should kind of just predict the sentence, complete your sentence, right? In that case, it can kind of prompt you the word and you go ahead and type it, right? You will be typing it eventually. It is not going, it is just going to prompt you the word. So in that case, which is a very lightweight application, you can kind of use stemming. So it completely depends on the use case that you're building and how light you want your application to be. If your application has to be very light, you have to use stemming, because it's very faster, it just chops off and gives you the root form. But lemmatization is like searching in a dictionary and giving you the right word. It is a heavyweight, so it depends on your use case. We don't have like a strict rule that you have to use this only in this case, this only in the other case. So I hope I was able to give you a brief view on when exactly you have to use what.
Yeah. The next question is word tokenization technique examples.
So you mean to tell like, see, it's as
Yeah, he
simple
wants
as that.
example.
Like if you take a single word, a single sentence, like uh, I could say like, my company was found in 2002. Okay, that is my simple sentence. And if you want to do tokenization, right, one tokenization you can just do is using a split. If I can give you a simple example, in Python, there is a split function, right? And in that split function, you can just pass the character that you want to use as the splitting character. So as I said, my company was found in the year 2002. It's a simple English sentence, and in between those sentences there'll definitely be a space, right? So I can just use a split function of Python and tell that the character that is going to split my sentence into smallest unit is a space, right? I can tell any number of space. I can use a regular expression and tell one or more space, right? So then what it will do, it will give me an output telling my as one word, company as the second word, was as the third word, founded as the fifth word, in is the next word, 2002 as the next word. So it just used the space and it gave me my word. So the exact same things can be done in the regional NLP also, but you don't have to use the split function and you don't have to pass the stopping words, right? They have built a wrapper around this Python split to handle that when you pass a language. So it does everything for you internally. You just have to call the function called tokenize and pass your input string. It is as simple as that.
That was very insightful. I hope he got his answer. We will be picking the next question, which is what factors can we expect to be varying in different vernacular languages? And can all those variations be assimilated with one model?
So the answer that I think I'll answer your second part first. So definitely you cannot have one model for all the vernacular languages. The reason for that is the dialect is very different. Like we were just looking at the Indian subcontinent, right? If you take Indian subcontinent itself, right? Our dialects are so different. Like if you take the South India, North India, right? There is so much variations. So if you have to build one model addressing all the dialects, everything, the model is going to be heavy and the efficiency is going to be really hard to bring it up to a big standard, because the training has to be done using a very large corpus accommodating all the different vernacular languages. It's going to take time, right? So that is why it is not kind of, I wouldn't say possible, because nothing is impossible. As of now, it is not the right thing to have one model addressing multiple vernacular languages. As long as the language dialects are similar, you can have one model. Okay, if the language dialects are very, very vast, like for example, you take the Indian language and you take the Japanese language, our dialects are so different, right? The pronunciations are different. So you cannot have one model addressing them, right? So that's the challenge over there. I hope I was able to kind of give you the insight on why you cannot have it. And to address to your first question, you told what are the different aspects of the language that we have to consider, right? Yes, sure,
Yeah, Rama.
Aditya. Was that? Yeah. So, see, for example, the languages that we were talking about is the Indian languages. We were talking about some of the nuances like their phonetics, right? Like how the word is pronounced. Based on that, how you infer that particular character and word also matters, right? So, for that, you need to have a phonetic vector associated with your particular characters that you are processing, right? So that is applicable when you are doing the language which is very phonetic variant like our Indian languages. So you will have to understand the history of the languages when you're trying to process them so that you can add the corresponding vectors. So this might not be applicable much for the Indian languages because we don't do much of the variations like how we do in the vernacular languages, right? Like pronunciation from your, from your throat and like folding your tongue and all those things, that doesn't matter much, at least from a larger perspective in English language, right? So you have to understand the languages that you're processing, then you have to take those language nuances. But generally all the Asian languages will mostly have a phonetic vector because they have the different pronunciation, and the way you pronounce them is kind of associated with the anatomy of our tongue and mouth and throat, right? So that is one thing to give you an example.
Thank you, Rama. The next question is, can you suggest any good libraries in Python for regional NLP?
So the three libraries that I spoke about, right? The INLTK, the Indic NLP, and the Stanza. All three are the Python libraries only. You can go and explore Indic NLP, the one that I showed you. There is a very good documentation. I'll see if I mean, if I give it in the chat, Aditya, or yes, you can pass it on to them. Is it? How is it? If I wanted to share a link, suppose
Yeah,
for
sure.
Yeah, yeah,
You
yeah.
can do that on the
that
chat.
that yeah, I will just paste it in the chat. That is very nice explanation is there, and a very good documentation is there. You can explore. So Indic is very nice to start off. This is based on my view because I have explored more on Indic. I might be biased, but to be unbiased, those are the three libraries that you can use. That is Indic, Stanza, and INLTK. Most of the people who are very familiar with Python, right, they would prefer INLTK. Why? Because they would have used NLTK, right, pretty predominantly when they're working with NLP. So that's why they would prefer INLTK. So it depends on your choice. You can explore any one of these three. So this is one link that's nice. I'm just pinging in the private chat if you want to pass it on. So you
Yeah,
can
we will pass it on, sir.
yeah, this is a nice thing. They clearly address the challenge and how Indic library kind of solves it. I hope I was able to address it.
Yeah, thank you, Rama. So the next question is, how can someone with no knowledge of regional languages work on regional NLP by just using the corresponding Python packages? Isn't this domain knowledge required?
Very, very good question. Okay, so the thing is, why we are having this Python libraries to reduce the burden at your end to implement things, right? So, for example, in tokenization, right? You internally, if you see tokenization, one of the tokenization implementation is using a split function in Python and passing the corresponding splitting character, right? So that implementation they have done and written a wrapper for it called tokenize, right? But when you are doing it for regional languages, if there is no Python libraries, the onus lies on you that you implement all of these functions from the scratch, right? That will be hectic for you. The main purpose of you as a Explorer is you are trying to build an application using the regional NLP so that you can cater to the need of people who are using a specific regional language. You are developing an application to help them, right? So your main focus and effort is towards the application development, understanding that your effort should not go in writing all the functions for your application from the scratch, right? It will take a lot of effort, right? So for that only you have this Python library. So the Python library are just going to reduce your burden of writing all the functions, like for tokenization, for word embedding, all those functions from scratch for the language that you're using, say for Hindi. But they are not going to remove the domain expertise that is still needed from your end. So what I'm trying to tell is these libraries are not going to give you the domain knowledge. They're just going to give you wrappers, but you still need to have the required basic domain knowledge, expertise when you are working with the language. No denial in that. Hope we were able to get the point, right? These are going to reduce your implementation effort, but they're not going to give you domain knowledge. Domain knowledge still has to come from your end.
Yeah, I think that answer works. Like why, like domain knowledge is like when it is required and when it is not. So I think the answer works. So I think that's all from the questions from the chat, and I guess we can just end up one last question from my side and few members of our club itself. So like, what would you suggest for the beginners, like for who are looking forward to the regional AI? Like, what projects can they do on regional NLP and yeah, sort of that. Please suggest some like points.
Definitely, yes. That's a good pointer. So to start off with, right, I would say that first try to understand generic NLP, right? We all know NLP, but we try to miss out the basic things of NLP steps, right? All the basic steps when you're processing a text, like the word embedding and the tokenization, right? And the name entity recognition. So all of this first try to understand with respect to English, okay? And then you can try picking up any one of the regional language packages that are available in Python, right? And try to use it for the language that you know. Simple. See, once you know NLP with respect to English, you know, okay, there is something called word embedding, right? Which is the vector representation of word. Why I need vector representation? Because then only my computer or the program will be able to process it better, and the similarities of the words, meaning of the words are well captured in a vector format. If you know the meaning of word embedding with respect to the English language, it will be easy for you to do the same in a regional language because you know Hindi, say for example, right? And in the Hindi language, how can you capture the meaning of a sentence, its contextual meaning using word embedding? That you can easily use the libraries that I've mentioned and just do the function call to see and understand the vector representation. So I would say go in that approach. That would be easy for you. Learn NLP basics in English language and then try to correlate it with one language that you know, any regional language which you are comfortable with, and start using this library. Once you get your hand dirty with these basic things, right? The basic steps of NLP using any regional language, then you can explore some of the upcoming models like the Mural that I spoke about, which is an open source project by Google. The last slide that I shared, right? The multilingual representation for Indian language. It is an open source project by Google. So you once you know how to do things using the regional language libraries, then you can try contributing for such open source projects. So that would be the flow of events that I would say for any newbie to explore. Hope
Okay,
I was able
thanks.
to address.
Yeah, definitely. Like I guess the beginners who are looking forward in the field of NLP, who they would follow your steps and get some hands-on experience, and also go for some opportunities in the future. So that was all from this webinar, and I hope you will be there in the next year's summit too. And I hope that everyone took a lot from this webinar, and it was quite informative and like it was great webinar. So thank you, ma'am.
Yeah, thank you, Yash, and thank you, the entire team, for this wonderful opportunity. And I'm very happy I could share some and learn from wonderful questions that you asked. Have a good day.
Yeah, sure. So let's end the broadcast. Thank you, everyone.